Hello everyone, welcome to my channel. So on the request of viewers, I am making this video, and in this video I am going to discuss Maths-1 paper of March 2021, the recent paper. So let's start with the section A. So section A, first question. Discuss the applicability of Rolle's theorem, f of x equal to x into 2 plus x e to the power minus x by 2 in the interval minus 3 to 0. So Rolle's theorem has three conditions. First is continuity, second is differentiability of the function, and the third is that the function should have equal value on the endpoints. So this function is a combination of three functions: x, 2 plus x, and e to the power minus x by 2. All these three functions are continuous and they are differentiable also. So we just need to check the value of this function at the endpoints. So let's see what is f of minus 3. Instead of x, just put minus 3 here. So minus 3, 2 minus 3 e to the power minus 3 by 2. 2 minus 3 will become minus 1. So this is equal to 3 e to the power minus 3 by 2. And f of 0, when you put x equal to 0, the value of function becomes 0. So you can see here clearly f of minus 3 is not equal to f of 0. So Rolle's theorem is not applicable because at the endpoints the value of the function is not equal. Now let's move to next question. Question number 2. Define gamma function. So gamma function is an improper integral given by this formula. 0 to infinity, integral of 0 to infinity, t to the power x minus 1, e to the power minus t dt, where x is greater than 0. We already know, now we have to prove this, that gamma of x is equal to x minus 1 factorial. We already know a formula of the gamma function, which is gamma of x is equal to x minus 1 gamma x minus 1. So we'll keep on using this formula again and again on the gamma function. Actually, this formula says that if we are finding out the value of gamma function on any integral value, then that is equal to one less integer into gamma of one less integer. Like if I am finding gamma 3, that is equal to 2 gamma 2. If I am finding gamma 4, that is 3 gamma 3, and so on like that. So if we have gamma x, so gamma x will be equal to x minus 1 gamma x minus 1. We can again apply this formula here. So it will be equal to x minus 1 x minus 2 gamma x minus 2. I'm just reducing one integer. One integer is being reduced and we are applying this formula. Again, we can apply it here. Again, one integer will be reduced. X minus 2 minus 1, it will be x minus 3. So x minus 3, gamma x minus 3, and so on like this. Will keep on decreasing one integer, and in the end, what we will get? We'll get x minus 1, x minus 2, x minus 3, so on to 3 into 2 into 1. Okay, and what is this value? This is x minus 1 factorial. And hence we have proved this gamma of x is equal to x minus 1 factorial. This completes question 2. Let's come to question number 3. Expand sine x in powers of x minus pi by 2. We'll use Taylor's expansion to do this. So f of a plus h is f of a plus h times f dash at a plus h square upon 2 factorial f double dash at a plus so on. So here you can see the powers of h are increasing. So we'll take h to be x minus pi by 2 and we will take a to be pi by 2. So taking a to be pi by 2 and h to be x minus pi by 2. So a plus h will become x. So f of a plus h is f of x. So f of a plus h will become sine x. So left hand side will get sine x and right hand side these things will find out. F of x is now f of x is sine x. So value of function at pi by 2 is sine pi by 2, which is 1. Now we'll find out the derivatives of sine x and the value of the derivatives at pi by 2. F dash at x is cos x. Value of cos x at pi by 2 is 0. Now f double dash at x, f double dash at x is minus sine x. Value of minus sine x at pi by 2 is minus 1. Then f triple dash at x is minus cos x. Value of f triple dash at pi by 2 is minus cos pi by 2, which is 0. Now fourth derivative, now if you will take fourth derivative here, derivative of cos x will be minus sin x. Minus minus will become plus, so it will again become sin x. So that means the value will repeat now. Okay, so the cycle is complete. It's a periodic function cycle is complete. Now we will these values will repeat 1 0 minus 1 0 1 0 minus 1 0. It will repeat now. Okay, now this 1 corresponds to this value here. Then 0 is for this, then minus 1 is for this, and then 0 again for this. That means the powers, the odd powers, that means the odd powers of x minus pi by 2, they will have coefficient 0. So odd powers will not appear in the expansion, only even powers will appear, and even power will have alternate sign, first plus and then minus. Okay, so the expansion, if we'll put all these values here in the expansion, so we'll get this. F of a is 1 plus h is x minus pi by 2, f dash at a is 0, then x minus pi by 2 square upon 2 factorial, f double dash at a is minus 1 plus x minus pi by 2 cube upon 3 factorial, f triple dash at pi by 2 is 0, and so on like this. Okay, now the values will repeat. So only even powers are coming, and the even powers are having alternate sign. So expansion of sin x will be something like this. 1, that means 0 power of x minus pi by 2 minus alternate sign. Okay, here it is plus sign, then here it will be negative sign. 2 power x minus pi by 2 square upon 2 factorial, then plus x minus pi by 2 upon 4 power 4 upon 4 factorial, and so on like that. Now next term will be x minus pi by 2 raised to power 6 upon 6 factorial with a negative sign. Okay, then the next term will be x minus pi by 2 upon 8 factorial with a positive sign, and so on like this. So this is the expansion of sin x in powers of x minus pi by 2. Now next move to next question. Question number 4. Compute AB minus BA if A is equal to 1 minus 1 2 1 and B is 2 minus 1 3 0. Very easy question. Just you have to do multiplication. So just write down these values. Write down the value of A. Write down the value of B. Minus, write down the value of B and write down the value of A. And you just have to do multiplication. I hope everyone knows how to do multiplication. What you have to do, you have to multiply first row with the first column, then multiply first row with the second column. Okay, then multiply second row with the first column and multiply second row with the second column, right? So let me write down here first. Let me show you once. So multiply first row with the first column. 1 into 2. 1 into 2 will be 2. 2 minus 3. Minus 1 multiplied by 3 will be minus 3. So the first will be 2 minus 3. Then multiply first row with the second column. So it will be minus 1 plus 0. Minus 1 into 0 will be 0. Then 2 multiplied by 2. 2 multiplied 2 by 2 is 4. And 1 multiplied by 3. 1 multiplied by 3 will be 3. Then multiply second row with the second column. So it will be 2 multiplied by minus 1 will be minus 2 and 1 multiplied by 0 will be 0. Minus, then again same kind of multiplication. Multiply first row with the first column. So 2 multiplied by 2, it will be 2 here. Minus 1 multiplied by 2, it will give me minus 2. Then 2 multiplied by minus 1 will give me minus 2. And minus 1 multiplied by 1 is minus 1. Now multiply second row with the first column. So 3 multiplied by 1 is 3 and 0 multiplied by 2 is 0. Then 3 multiplied by minus 1 is minus 3 and 0 multiplied by 1 is 0. Okay, so let me just write these things. So it's equal to this. Okay, and now you just have to do calculations. This is just plus minus, so 2 minus 3 will give me minus 1, then minus 1, then 7, then minus 2, minus, so it will be 0, minus 3, 3, minus 3. Now just subtract term wise. Okay, subtract the element of the matrix term to term. So it will be minus 1, minus 1, minus 1 minus of minus 3 will become minus 1 plus 3, so it will be 2. Then 7 minus 3 will be 4 and minus 2 plus 3 it will become 1. So this is the answer. Now next question. Question number 5. Find the rank of the matrix. So it's very easy. You can reduce it to echelon form. Firstly, let's just bring 1 at the first place. So interchange first and the second row. 1 to 1. 2, 4, 2 at the second place and third row remain as it is. Now use the operation. R2 goes to 2 times R1 and R3 goes to 5 times. R3 goes to R3 minus 5 times R1. So when we use this operation, this will, here it will become 0 and here it will also become 0. Rest you can see 4 minus 2 times 2, 4 minus 4 will become 0. 2 minus 2, 2 minus 2 will become 0. 10 minus 10 will become 0 and 5 minus 5 will become 0. So there is only one non-zero row. So if there is only one non-zero row, rank is 1. Rank of this matrix is 1. Next question. Question number 6. Define kernel of linear transformation. So kernel is set of those elements whose image is 0. Okay, kernel in a linear transformation is a collection of those elements whose kernel is 0. Okay, so if there are two vector spaces V and W, okay, and T from V to W is a linear transformation, then the set of those vectors in V whose image under T is 0 is called the kernel or null space, and it is denoted by N of T, and mathematically in the form of set it is given like this: all those elements of V such that image of V is 0. So this is the kernel of linear transformation. The next question, question number 7. Prove that the set of vectors containing 0 vector is always linearly dependent. Okay, so let us assume that V is a set containing 0 vector. So we just assume a set V which is having the vector 0. So I have defined the elements of V like this: V1, V2, V3, and there is some 0 in this vector space. There is one 0 vector. So if we take the linear combination of these vectors and we'll put it equal to 0, if we assume this linear combination, so if we find out A1, A2, A3, you can see if we take A1, A2, A3 to be all 0 and 1, A4 to be non-zero, then this linear combination is giving us the answer 0. Okay, but there is one non-zero. So if we take A4 to be non-zero and all other to be 0, okay, but A4 is non-zero. So these vectors will become linearly dependent. So set of vectors containing 0 vector, that's always linearly dependent. Okay, so this proves the set V is linearly dependent. Next question, define orthogonal matrix. Very easy. Square matrix P is said to be orthogonal if P transpose multiplied by P is equal to I, and P into P transpose is also equal to I. The question number 9. If alpha is eigenvalue of non-singular matrix A, then prove that alpha inverse is eigenvalue of A inverse. So if alpha is eigenvalue of A, then there exists a eigenvector also x such that A times x is equal to alpha x, right? Now we can write x as A inverse alpha x, right? If I multiply by A inverse both sides, I get x equal to A inverse alpha x. Now x is equal to, alpha is a scalar, alpha is a number only, so it can be taken outside. It is equal to alpha inverse A inverse x. Now it can we can bring alpha this side, so it is 1 upon alpha x is equal to A inverse x. So A inverse x is equal to 1 upon alpha times x. So this means 1 upon alpha is the eigen value of A inverse, because x is non-singular, x is non-zero. X is non-zero vector, and A inverse time x is coming out to be 1 upon alpha times x, and this satisfies the condition of 1 upon alpha being the eigenvalue of A. So this proves 1 upon alpha is eigenvalue of A inverse. Last question, 10th question, find product of eigenvalues of A. So we know the product of eigenvalues is equal to determinant of the matrix. So determinant here is 10 minus 4, so which is equal to 6. So this completes section A of March 2021 question paper. Please like, share and subscribe my channel, and feel free to ask problem. In the next video, I'll come up with section B of this question paper. Thank you so much. Have a good day. Take care. Bye bye.